Hello. So in today's video, we're going to look at considering the maximum and minimum values of sine and cosine functions. So consider the sine and cosine graphs here. So we've got y equals sine x there, and we've got y equals cos x on the right here. These graphs here, obviously, we've got pi radians there. We've got 2 pi radians there, pi radians in the middle there, and 2 pi radians at the end there. So what are the maximum and what are the minimum values of these graphs? Well, I mean, here we can see the maximum value of a cos graph is what? A sine graph is 1, and obviously a sine graph has a period of 2 pi. It repeats itself every 2 pi radians. So the maximum value for these sine graphs is always going to be 1. And we can see that the minimum value is always going to be -1. So again, these sine graphs are bounded between -1 and 1. So we know that the min for sine is going to be -1, and the max for max for sine is going to be 1. And exactly the same idea with this cos graph, because again, the cos graph is just the sine graph shifted, basically shifted to the left by pi/2. That's what the cos graph is. So again, it's bounded between -1 and 1. So we can see that the maximum value for cos, so max is again 1, and the minimum is -1. So exactly the same as the sine as well. Now, how about if you've got a transformation? So let's say we've got a transformation. I'm just going to make a note that A, B, C, D are just all real numbers. So any number on the number line you like. We've got these numbers, and we've got this transformation A sine bx plus c plus d. What is the maximum values of this? So what are the min and max values for this? So when we think about the maximum and the minimum of a graph, or the maximum or the minimum of a function, we're worried about the y coordinates. So we're only worried about, the maximum y value on the graph, the minimum y value on the graph. That's what we're interested in. So we've done graph transformations before where we followed the procedure. So we did the c first. We do the translation by a vector of -c over a in the so -c0 to the left. That's your translation with a plus c there. You then do your scale factor of 1 over b parallel to the x-axis, to a stretch parallel to the x-axis by 1 over b. You then do your y stretch, your stretch parallel to the y-axis by a factor of a. And then you do your translation upwards or downwards by a vector of 0d. So you always do it in that order. So first, second, third, fourth. You always do your transformations like that. And we've been through this in previous videos where we go through we did a previous video where we actually went through the order in which you do function transformations. But the thing to understand here is that these two transformations, your first two transformations, only affect the x coordinates. So 1 and 2. So transformations 1 and 2 only affect x coordinates. So they don't change the maximum or the minimum of your graph. They either translate your graph to the left or right, or they squish or stretch your graph parallel to the x-axis. So the inputs into your sine and also your cos function, they don't affect your x coordinates. So when we're thinking about maximum and minimum points, we're thinking about y values on the graph. But these first two transformations only affect the x coordinates, so we don't need to worry about these. But 3 and 4, so transformations 3 and 4, but 3 and 4. So 3 is a stretch parallel to the y-axis by a factor of a. So now we're stretching the graph by a factor of a, upwards or downwards, and this is now a translation either upwards or downwards by d. So 3 and 4 do affect y coordinates. So remember the order in which we do things. So firstly, we're going to stretch our graph by a factor of a. So let's say you've got a sine graph like this. It's your sine graph there. If you stretch it by a factor of a, you're now going to get the y values all multiplied by a. So you get a graph like this. So this is now y equals a sine of ... whatever this may be in the middle here. It's quite irrelevant really, as long as it's like a linear factor bx plus c in there. So now we've stretched it upwards like that. And now our new maximum value is going to be a there, and our new minimum value is going to be minus a there, because a times by 1 is equal to a, and a times by minus 1 is equal to minus a. So now the maximum becomes a and minus a, but we've got this plus d that we're adding at the end of the graph. So now we're going to shift the graph upwards by a factor or by d units to get something like this instead. So now your new maximum up there is going to be a plus d. So therefore the maximum, so maximum for this graph is going to be a plus d, but the minimum is going to be minus a plus d, because when we stretch it by a factor of a, the minimum was minus a, but now you're going to add d to that, so you're going to add d upwards, or it could be downwards if d is a negative value, of course. You're now going to get a new minimum point here at minus a plus d. So your minimum is minus a plus d, your maximum is now a plus d. And exactly the same thing is true of the COS graph. So again, you've got a COS graph like this. Again, these transformations here, transformation number 1, the translation by a vector of minus c0 in the x direction, and this stretch by a factor of 1 over b parallel to the x-axis, these only affect the x-coordinates, so only affect x coordinates, so they don't change the maximum or the minimum of the function, because that's to do with the y coordinates. But of course, transformations 3, our third transformation, and our fourth transformation, they do affect our values, our y values. So before with cos, we've got a maximum of 1, minimum minus 1. Now when we stretch it by a, we're going to get a maximum of a and a, sorry, let me try and do that again. So through 0 there, through 0 there, we now get a minimum of minus a and a maximum of a. And then lastly, the final transformation is to add the d at the end to translate this upwards or downwards by a factor of d, or by d units, I should say. So now we're going to move it up, shift it up to a plus d. And so we get something more like, something more like this. And now your new minimum point there is going to be at minus a plus d again. So the maximum again is the same as before with the cos graph, because remember the cos graph is just the sine graph translated to the translated left and right. So your maximum now again is going to be this a plus d, and your minimum for your cos graph, this translated or transformed cos graph, is going to be minus a plus d. So your two values there. So in summary then, the minimum value of a sine of bx plus c plus d, or a cos bx plus c plus d, is equal to minus a plus d, and the maximum value of a sine of bx plus c plus d, or a cos of bx plus c plus d, is going to be a plus d. And that's for the reasoning that we just said. So as like a brief example then, if you've got y equals 3 sine 100 x minus 100 minus 4, then your maximum value is going to be 3 take away 4, which is minus 1. And your minimum value is going to be equal to minus 3 minus 4, which is minus 7. So yeah, that's just a brief summary of how you can work out the maximum and minimum values of these transformed sine and cos graphs. And you just follow the rule that we did here. So minus a plus d for your minimum and a plus d for your maximum.